get a common base on each side. If we can't get the same base on each side, we have to have a different strategy for solving it. So that's what we're going to look at now. So the property that we are going to use is if x is equal to y, then log base a of x is equal to log base a of y, and vice versa. So this is telling us we can either add a log to both sides of an equation or take it away if it's on both sides. It has to be the same base on both sides of the equation, and there can only be one of them for this to work. So for example, if I asked you to solve 8 to the x power equals 21. So yesterday we would have tried to get a common base on this, and that's still the best option. But is there a common base? No. 8 is 2 to the third power, but I can't do 2 to a power and get 21. What we can do is add a log on each side. Now I'm going to always do log base 10 or natural log, which is log base e, because those are the two buttons that are on your calculator. Anytime you see a log without a base written, it's just assumed to be 10. How does this help me? Because initially this looks worse. Think about properties of logs. What would that exponent do? Okay, exponents can drop down front. So what I have is x times the log of 8 equals the log of 21. So how would I get x by itself? Divide. So x is the log of 21 divided by the log of 8. You can't cancel those logs. That's our expression. We are going to put these in and get decimals. They are not nice decimals, so we'll just go to 4 decimal places. The biggest issue that people tend to have, especially if you're using these graphing calculators, when you push a log, so I want to see where it is, like 3 buttons above the on button, there's log. When you push the log button, it opens a parenthesis, so you have to make sure you close it. So if I do log of 21 divided by log of 8.
Is natural log like the ln, or do you have to do something?
Natural log is ln. Yes.
We both
Yeah. So for yours, just have to push it twice. One trick for the graphing calculators, if you want to make sure you're plugging these things in, if you hit alpha, that's the green button, and the y equals button right above it, and then enter, it will set it up as a fraction. So you can make sure, especially when we have more complicated expressions, you can make sure that you have the correct pieces on top and bottom. Can I check these? Yeah, if I type in 8 to the 1.4641 power, is it going to give me 21 exactly? No, because I rounded. However, it should be very close. And if I type in, I get 20.9997, so I can check my work that way. Let's look at this one. Right, these expressions can get ugly, but it's involving all the algebra that we've already used. It just looks different when we have exponentials and logs. Can I get a common base between 5 and 8? So our properties of logs say you can add a log to each one. What happens now? Exponent comes down front. I am putting this in parentheses because it has two terms. From here, I am trying to solve for x, but I have x's on both sides. So I have to distribute. This log 5, no matter what I multiply it with, I can't change the 5. So I'm distributing this. These are just going to be the coefficients. So it's just 2x log 5 minus 3 log 5. On the other side, we get x log 8 plus log 8. I'm looking for x. Notice I have two terms with x and two without. So I need everything with the x on one side. So I have my 2x log 5. I'm going to subtract over the x log 8. This 3 log 5 doesn't have an x, so I'm going to move it to the other side. So I'm putting everything with an x on one side and everything without an x on the other. I know it's long. We're almost there. 2 steps. Can I actually subtract these things? No, they're not like terms. So what else could I do? One thing before we divide. Okay, you could try using properties of logs to condense things. But it's going to put x back into an exponent, so maybe not super helpful. Let's take out an x, let's factor it. So then it would be x times 2 log 5 minus log 8. So now to get x by itself, we divide that whole thing. This is the longest problem we will ever have with Lindy. So this is as complicated as it can get right here. I strongly recommend when you go to put this one in, if you are using the non-graphing calculators, then I want you to push that N over D button so you can see it as a fraction. If you're using my graphing ones, hit alpha y equals enter so you can view it as a fraction. Every time you push a log button, it opens a parenthesis. You have to make sure and close all of those. I want everybody to type this in now. We should get 6.062. If anyone needs me to look at their calculator.
Strong. Oh, I type it in the fraction first.
Yeah.
It helps, otherwise we just have to add more parentheses here. So you can do it all out, it's so easy to type in.
I would do that. I was in high school, I had physical science with Mr. Galloway. She was the science teacher.
That does not seem like something you would do.
Yeah, yeah. All I really remember was if somebody fell asleep, we would all go outside and stand by the windows and watch them until they woke up. That's what I remember, that class. All right. Any questions on this one?
Yeah.
Let's try another one like that. So these are the hardest ones I can possibly give you. So we'll try some of the hard ones first.
How many decimals was
Don't forget to always check for a common base. Logs will give you the answer, but it is longer. So when a common base works, that's going to be faster. And I may throw some of those in occasionally. Can I get a common base between 3 and 0.4?
No.
No. So what do? We add our logs. Exponent comes down, please put that in parentheses because it's two terms. I need those parentheses to show me that whole thing is multiplied by my log. Then what do we do? So we do 2x log 3 minus log 3. Equals x log 0.4 plus 2 log 0.4. Now what? Mm-hmm. Two terms with the x need to be on one side, the terms without it on the other. So I will subtract over my x log 0.4 and add over my log 3. Now what? Take out the x. All right, so we have x times something, so to get it by itself, we divide. Again, strongly recommend viewing it as a fraction when you plug this in. And remember, every time you push log, it opens a parenthesis, so you have to close all of them.
I thought the 3 was the 2 log. So then did that switch? Right here. I thought the 3, so how does that switch? Or did I just write it down?
No, we have the same thing. It's just this divided by that.
You're,
So
you don't have me
is that on the bottom? We have the same thing. You don't have
So why
to
does it
erase.
go on the bottom?
Because we divided it. It's x times that parentheses, so we're just dividing that
So
parentheses.
this is on top, this is on top.
Mhm. This is what I have on top of my fraction up there. And then you divide it. This is fraction of the x y. All right, what'd you guys get?
-0.235.
Perfect. All right, and if we wanted to, we could check it by plugging it into the original, both sides, making sure they gave us the same decimal.
I just not gonna
All right, so far so good? I want to try some more of these to make sure we're on the right track. Let's not round to the nearest thousand. Let's just keep doing 4 decimal places. So if I asked you to solve this one, we have e to the x squared equals 200. E to the x squared equals 200. Can I get a common base between e and 200? No, so we add a log. It can be helpful. Natural log, that ln is log base e. So typically if I have a problem with e's, I use ln. You do not have to. It will just make it a little bit nicer. And I'll show you why in a second. So if you don't like this, you can stick with the regular log and use that log button. You'll get the same answer. At this point, exponent comes down. You can divide by the natural log of e, or if you recognize it, natural log is log base e. What is log base e of e? 1. So you can drop that. Anytime you get a natural log of e, it just goes away. So if you didn't catch it, that's fine. You'll divide it over. You'll be divided by 1. It doesn't change anything. It just makes our problem a little bit nicer. We have fewer logs if we catch it. How do we get rid of a square? And if we add square root, we need, so x equals plus and minus square root natural log 200. It's the ln button, so it's right under the log. Again, if you don't like it, do your log base 10 on every problem, and it will give you the exact same answer. All right. On B, this property of adding a log only says I can add 1 log on each side. So on this problem, what should I do first? Combine them. If I am multiplying these e's, what do we do with their exponents? So 2x plus 1 plus negative 4x would be negative 2x plus 1.
Do we have to put 2 here or just
No, it would just be e. So you only add the exponents. Now what would we do? Add a log. You can do log base 10, or if you want, you can do natural log. Over here, it's the natural log of this entire side, 3e. Exponent comes down. If you catch it, natural log and e cancel each other. It just turns into 1. It doesn't work over here because we have a 3e. So what would I do to get x by itself? X is natural log of 3e minus 1 all over negative 2. Okay, so if I type that in, there's a couple different places with an E on your calculator. The graphing ones, if you hit second, the natural log, it brings 1 in, but forces you to do an exponent. You would just put in a 1. Or if you do second, the divided sign, it brings in a regular E.
It's going to choose you to an exponent.
All right. Anyone else need help with the E? Let's try a couple more.
Yeah, I'm like typing.
I think you could do your
Okay.
Maybe the E to the first.
Yeah.
E to the
Can I multiply the 8 and the 3? No, order of operations says you have to do exponents before you multiply. So what would you do with that 8? Divide it. So we have 3 to the x equals 5 over 8. Then what? Add a log. Do I have any benefit to add a natural log on this one? No. The only time that saves me any work is if it's an E. Right, so the benefit of this is the x comes down, so we have x log of 3 equals the log of 5/8. So then what do we do? So x is the log of 5/8 divided by the log of 3. Make sure, close your parentheses. You can always check by plugging it back into the original. All right. How about one final problem for today, and then you guys can try some and ask questions. Thoughts? What should we do first? Subtract 1. We have to get that exponential piece by itself. So the thing with the exponent, we have to isolate that. So if I subtract my 1, then what? Question. What's 6 divided by 5?
1.
Why is that helpful? We have the same base. What's the exponent on this 1.2? 1. So you don't have to add the logs. So we get x to be 1. Now, could you have added logs? Absolutely. And you would still get there. It's just going to be a longer process. So just watch for those happy little coincidences. All right. So we have about 15 minutes. If you look on Classroom, I posted the 4.5 homework. We are doing day 1 only, so that's 1 through 12.
So,